Hello, Abhishek.
Good evening, sir.
Good evening. Please introduce about yourself.
Good evening, sir. My name is Abhishek Shivam. I hail from Bokaro Steel City. I started my education journey from Guru Gobind Singh Public School, where I completed my class 10 and class 12 with good marks. Due to my passion in engineering, I pursued BTech in production engineering from VIT Sindri. During my engineering years, I grew close to subjects like strength of materials, manufacturing processes, like casting, industrial engineering, which ultimately led me to succeed in my batch, ultimately becoming the grand topper. After that, I got placement in TCS, and from last 3 years, I'm working in TCS as a Salesforce developer.
Okay. So, Abhishek, why you want to join HAL? You are already working in a MNC in a good profile in TCS. So, why you want to switch your profile, your job?
So, first of all, I'm very thankful for the TCS to giving me that opportunity during that pandemic time. But sir, from my BTech days, my core competencies lies in the skill of production engineering, and I want to pursue my career and align my career along in an industry which is core in nature, and actually such industry where I can use my skill set which I have learned in engineering to to contribute to its growth.
Okay. Abhishek, you are saying that HAL will be using your skill set in a better way, in an efficient way. So, what do you know about HAL? What HAL does? What is the job profile of a management trainee here?
Sir, HAL is India's one of the largest defense PSU. Sir, now HAL is responsible for making indigenous aircrafts for our country. Recently, HAL has produced LCA Tejas, and which has helped our Indian Air Force to strengthen itself, thus reducing the impact on our economy or due to less imports. Also, sir, HAL has made our economy more stronger because it is exporting indigenous made aircraft to other countries like Egypt and Argentina. So, sir, HAL has evolved as a global player in this market, and it's progressing by leaps and bounds. And I see that I can contribute to this growing industry along with my career, and my core skills are very suitable, like in manufacturing and metal forging, which happens in HL. That is why, sir, I want to join HL.
Okay. Abhishek, do you know some other company or organization that may be in our country or it may be in other outside our country that whose work is similar to HL? Do you know any other companies or organization? Maybe government, maybe public, maybe private.
Yes, a few of the organization which are similar in nature with HL. First is Boeing, second is Airbus, third is Honeywell. General Electric of America is also one of the producers of aircraft.
Okay. And Abhishek, do you know when Jharkhand has established? Because most of your life you have spent in Jharkhand. So when Jharkhand was separated from Bihar, do you remember that date?
Sir, sorry, sir, I'm not aware of that.
Okay. Abhishek, in recent years, not all PSUs, but some of the PSUs, in fact, not all departments, but few departments have gone to privatized. Like you can say that Airport Authority of India is managing the airports, but in most of the airports, the GMR has took the contract from them, and they are having only the role of supervision, Airport Authority of India. So for the growth of our country, for the development, for the facilities to the citizens and people, is it good? What are your views on this?
On privatization.
Yes.
Sir, uh, as for our government motto, that it says that government has no business in doing business. So actually, government wants us for for this country as large as India. It is not possible for each and every one us to join government sector. So private sector has a role to play. Thus, privatization has some of its benefits. Like if you want to give employment at a large basis, we have to go for privatization because government is not will not be able to pay such a large population of our country because it has other resources to other works to do. But at the same time, sir, there must be few industries which should not be touched by private industry, like defense sector comes under such premises because it is very close to our national defense, and a confidential nature of this industry should only be governed by the government. Thus, privatization should be there, but up to a particular limit.
Okay. Abhishek, my last question to you. Where you see yourself 5 years down the line, or after 5 years, where you see yourself
Sir,
in
if I
terms of
get,
professional career?
sir, in terms of professional career, sir, uh, I want to I want to join a such organization where I can grow and develop my skill. It is evident from the fact that I am working in the IT sector from a non-coding background to coding background. I have a strong, quick learning capability, and I'm highly flexible to learning new things. So, sir, future holds new challenges, new opportunity. So, in new 5 years, sir, I want to strengthen of my skill and grow myself to maximum potential.
Okay. Thank you, Abhishek. Yes, sir, you can take.
Okay.
So,
So Abhishek, how are you?
good evening, sir. I'm fine.
Okay. So Abhishek, you said your favorite areas are production, industrial, and also your BTech is related to the same branch.
The strength of
So,
material also.
strength of material also. So I would like to ask you, like, what are the various applications of welding? Like, which process of welding is getting used in aerospace industry?
Sir, the first process which comes in my mind is tungsten arc welding, TIG welding, because this process has capability to do precise welding, uses titanium electrodes which are non-consumable in nature. So second is plasma arc welding. Because of high temperature, it is able to it is able to weld very materials which are high in melting point, like titanium, which is used which is used in this industry.
You are saying titanium. Is it titanium or tungsten?
No, sir. Plasma arc welding is the second
Okay.
welding which is used in this industry, because it has the capability to weld those metals which are having high melting point.
Okay. What do you understand by electron beam welding?
Sir, electron beam welding is an advanced welding process where the stream of electron is bombarded on the welding materials in order to achieve precise welding with very small amount of weld buds and negligible heat affected zone.
Okay. So you also have talked about castings.
Yes,
So
sir.
when I'm talking about casting, you would be knowing like there are some sand molds. So when the permeability is maximum for what amount of moisture content?
Sir, unfortunately, I'm not able to recall, sir.
Okay. So related to strength,
Sorry, sir.
related to strength of the mold, what is the amount of moisture for maximum strength?
So it should be 5%.
Okay. For strength, it is 5%. Okay, fine. So one more thing I would like to ask you, like you said, strength of material is also in the list of your favorite ones. So in the strength of material, you study a topic name as core, kern, or kernel in the columns.
Yes, sir.
What is that?
Sir, it is the area on the columns up to which we can do safe loading. It is, and up
Up
to
to
which
safe
the
loading.
yes, sir. And it
What
will
is
not buckle.
it will not buckle.
Yes, sir.
Okay. So one more thing I would like to ask, like related to stress strain diagram.
Yes, sir.
What is proof stress?
Sir, sir, unfortunately, I'm not able to recall, sir. Proof stress.
Okay. So you must have studied Mohr circle.
Yes, sir.
So like in 2D state of stress, we make a circle.
Yes,
So
sir.
for 3D state of stress, what we will get? Sphere, ellipse, or what?
So in 2D, 3D space of stress, we will only get circle only, sir.
What?
Which is Sir, it will be a circle, sir. Circle containing two small circles.
A circle containing two small circles.
Within it.
When Mohr circle becomes a point?
Under hydrostatic state condition.
Under hydrostatic state of stress.
Yes, sir.
Okay. So can you tell me about like in the theory of machines when we study gears, there is a worm and worm wheel gears.
Yes, sir.
So you must be aware that worm is driver, worm wheel is driven.
Yes, sir.
Can we have opposite of that?
Yes, sir. Theoretically, we can have opposite of that, but sir.
So practically, why we cannot?
Sir, maybe because of its gear ratio is not correct.
Gear ratio is not correct.
Means.
Okay. So what is when you study metrology and inspection?
Yes, sir.
So you must have studied there many things like limits, fits, tolerances,
yes, sir.
allowance. So what is allowance?
Sir, allowance is the difference between the maximum material limit and minimum material limit.
Okay. So whenever we are talking about types of fits and types of tolerances, you must have studied clearance fit, interference fit,
yes,
transition fit. Okay. So what is transition fit out of that?
Sir, transition fit is such fit when the maximum hole size, is greater than the maximum hole size is greater than the maximum shaft size is greater than the lower limit of the hole. So basically, the dimensions lies between. So transition fit is such a fit that it can interfere also, or it can go to clearance also. Because it lies between the upper material limit and lower limit of the shaft.
Okay. So I would like to ask you one question from computer integrated manufacturing. That is, what is BLU, basic length unit? How you will define that?
Sir, it is defined as the smallest distance traveled. It is defined as the smallest distance travel when 1 pulse of electricity is given to it.
1 pulse of electricity is given.
1 pulse of voltage is given to them.
Okay. So what is the difference you find in NC and CNC?
Sir, NC stands for numerical control. So it uses predefined part programming with the help of punch code. But in CNC, we have a computer control. There we do not require punch control. All the punch control is predefined set of instruction. But in CNC, we can give custom instruction at the instantly.
Okay. Can you tell me, like when you study the crystal structure part in material size, you must have studied a number of properties like coordination number, you see average number of atoms.
Yes, sir.
So out of these, like you study a number of terms there. So when we talk about ductility and brittleness and effect of alloying element, they depend on which of that characteristics of unit cell?
Sir, sir, one of the things I can tell is that atomic packing fraction and the presence of the metals, like in BCC, sir, although it is 68% empty, but it is not much ductile compared to FCC because the spaces are distributed. But in FCC, although it is 72% packing fraction is there, but the main space is in between. So holes are not distributed, thus it is more ductile. Like aluminum is FCC, and its atomic fraction is 72, but still it is a ductile material.
So atomic fraction is 72 or 74?
So 72.
72.
Yes, sir.
What about simple cubic?
68%.
Simple cubic is 68%. And then what is BCC?
BCC is 68%. It simple cubes. Some I'm forgetting that.
Okay, fine. So one more question from strength of material and machine design. Like you have studied about theories of failures.
Yes, sir.
What is the need for theories of failures?
Yes, sir. So whenever a complex state of stress arises, which is 3D in nature, then we are unable to design the materials. In that cases, some hypothesis has been given to us in order to design those materials, and in this we compare it to the universals. We compare it to the UTM machine stress, sir, to
So
designing the final material.
you said in 3D. What about 2D combined loadings?
Sir, even 2D combined loading, sir, we can apply theory of failures, and we can equate it with the results of universal testing machine results in order to design the final material.
Okay. So over to you, Chandra sir.
Hi Abhishek, how are you?
Good evening, sir. I'm fine.
Good, good. So, what was today's news headline? Have you read the newspaper today?
Sorry, sir. I have not read today's newspaper.
Okay, fine. So, other than these subjects which you have mentioned, production, industrial, and strength of materials, other than these subject, any other subject which is your favorite after these?
Sir, fluid mechanics.
Fluid mechanics. Have you? Okay. So, in fluid mechanics, what is the difference between pressure and stress?
Sir, pressure is a scalar quantity, but stress is a tensor quantity. So pressure is the external effect, but the stress is the internal resisting force developed in the material.
Mm-hmm. Okay. So, what is the pressure of a human blood?
Sir, I'm unable to recall the actual value of that.
Mm-hmm. Okay. And atmospheric pressure?
Sir, the atmospheric pressure is 101.325 kilopascal.
Kilopascal. All right. How it comes? Means how atmospheric pressure is measured? From where we have got this value?
Sir, we can measure atmospheric pressure with the help of barometer. Sir, we can use mercury column also, sir. The length of a mercury column under atmospheric pressure is 760 mm of Hg, and if we apply formula P equals to rho gh, where rho is the density of mercury, g is the 9.8 meter per second, h is the height of the mercury column, we will get this value.
Okay. So what is rho mercury? Rho of mercury?
Sir, it is 13,600 kg per meter cube.
Okay. And what is the value of G?
9.8 meter per second square.
9.81. And H?
Sir, H is 760 mm of Hg.
Okay. Have you ever multiplied these three terms and got 1 ATM?
Sir, it is not exactly 1 ATM. It is 1.01, 101.325 kilopascals.
Are you getting this value by multiplying these three terms?
Sir, we will get a value close to it. Not.
So why there is a difference? We will not get 101.325. That is for sure. But any reason for the variation and why this is taken as 101.325 only?
Sir, reason for variation may be due to the environmental condition or the extra temperature. No, sir. It may be due to the environmental condition. There may be some variation, but we have taken this as a standard value.
All right. So in cooking, we use pressure cooker most of the time. Why do we use pressure cooker?
Sir, in pressure cooker, when the water boils, sir, it converts to steam, which has more latent hidden energy, and as well as the pressure is also high in the pressure cooker, which helps us to cook the food very fast and easily when compared to heating on without pressure cooker.
Okay, so cooking is fast in pressure cooker.
Yes, sir.
It will become slow without the pressure cooker.
It will become slow, or it will consume more energy also, sir. The more
Which
energy.
will consume more energy?
Sir,
the vegetables or what?
no, sir. Cooking without pressure cooker, if you are not using pressure cooker as a cooking utensil, then the other utensil will consume more energy. And pressure cooker helps us to save that energy. Energy which we supply in form of heat.
What is the boiling point temperature of water?
Sir, boiling point temperature of water at normal at 1 atm is 100 degrees Celsius.
And what will happen to boiling point temperature in a pressure cooker?
Sir, if pressure increases, then the boiling of water temperature will rise.
It will be more than 100.
More than 100.
So if the temperature is more than 100, and if we use pressure cooker, then to make the water into steam will take longer time, isn't it? To attain 100 degrees Celsius is quite easier compared to attain 110, 120, 130 degrees Celsius. So how you are saying it will consume less energy? In my opinion, it must consume more energy because the boiling point temperature has increased.
Sir, but the increase in pressure does not happen instantaneously. Means the pressure increase happens slowly. During that time, appropriate heat might have be given to the pressure cooker.
Okay. Are you sure that is the reason?
Sir, I'm not sure.
All right. What is the shape of a nozzle?
Sir, nozzle is a device which converts the pressure energy to kinetic energy. So its shape should be converging shapes. The final area should be smaller so that there will be increase in velocity as the area is less.
Okay. Have you ever seen the diverging type of nozzle?
Sir, I have not seen the diverging type of.
Are you aware that there are nozzles which are having diverging shapes?
No, sir.
You have never studied about diverging type of nozzle?
Sir, I'm unable to recall.
All right. Next question is from the thermal engineering.
Yes.
What is the difference between enthalpy and internal energy?
Sir, internal energy of a system is a function of internal energy of a system. Sir, it is a product of it is a function of temperature, sir. For ideal gas, internal energy is a function of temperature, but it is mainly used for the closed system. When we analyze closed system, we take into account internal energy. But enthalpy is the sum of internal energy plus pressure and volume. It is used in the analysis of open system.
That is the mathematical definition. I wanted to know why do we require enthalpy where internal energy is already there? What is the general difference between these two values?
Sir,
You have given the formula.
Sir, whenever we are dealing with a closed system, it has internal energy. We do not go for the enthalpy. But whenever a system where the mass is incoming and outgoing, there we track the enthalpy of the system for the energy change. Because internal energy is also the part of enthalpy in that.
So you mean to say the closed system does not have enthalpy? Means enthalpy have no significance if the system is a closed system. Is it?
Sir, although we can find for ideal gas, but sir, here I'm not aware of this.
Okay, fine, not a problem. If we use petrol in CI engine, what will happen?
Sir, because CI engine uses compression for the combustion of the gases. So, sir, and in petrol engine, a spark plug is used. So, sir, when we will use petrol there, so maybe the fuel will not get ignited at the right time, or because sir, we are not using spark plug in the diesel engine, so there may be problem in ignition of fuel.
There will be problem in ignition.
Yes, sir, because of absence of spark plug.
Okay. One last question from my side, then Surasal will take over from here. How do you define third law of thermodynamics?
Sir, this law states that the entropy of the system approaches zero at the entropy of the system. Sir, at 0 Kelvin Celsius, the entropy of the system does not. Sir, I'm missing the last statement. Sir, at 0 degrees Celsius, the entropy of the system is constant.
Entropy of a crystalline structure, right?
Entropy of the structure does not change.
It will be zero.
Will be zero. Yes, sir.
All right. Sir, over to you.
Okay, sir. Hello, Abhishek.
Good evening, sir.
Good evening. So, how is your feeling for this interview?
Sir, actually, I'm prepared in production engineering. And yes, sir, I'm feeling fine.
Fine. Okay. I was just seeing your resume and I was looking for that for 4 weeks of duration, you have done ultrasonic testing of grinding rolls. Can you elaborate what actually you did for 1 month? It's a huge time.
Yes, sir. So we went to Bokaro steel plant. There is a RGBS shop, which stands for roll bearing grinding shop. Sir, in that shop, the rolls from cold rolling mill and hot rolling mill comes for the maintenance. So, sir, in our project, our task was to find the reason for the failures of the rolls, and to give the proper recommendations and what should be the proper practice to remove or to delay those roll failures.
So in that 1 month, have you identified any practical failure, like any one common failure that you are observing?
Sir, most of the rolls which were indigenous produced by our country, sir, in those failures, sir, there what was happening is that there was when their roll was suffering from temperature change. So, sir, there was a change of austenite to hard martensite iron. So, because of that, the rolls were becoming hard, and that is why spalling is a one type of failure in which the chunks of roll from the surface fall out. So that was happening. That was a major concern for our study.
So, what was your remedy for this?
Sir, we concluded that there needs to be a periodic maintenance of the rolls at certain time, and non-destructive testing should be used because those roll failures, because some defects were under the surface which cannot be detected. So we use non-destructive techniques in order to identify those cracks and to grind it to remove, and proper grinding should be done to remove it.
Okay, so you did some NDT over there.
Yes,
You
sir.
proposed that NDT should be done.
Yes, sir. NDT was done there, sir. I did.
Done. Okay. So can you tell me what length or dimension which NDT was using? First of all, tell me that.
Yes, sir. So we were using, sir, ultrasonic testing. We are using, sir. In that, sir, it was composed of three things. It was composed of a pulse generator, which uses a high voltage in order to produce pulse. The pulse was sent to transducer, which was generating high frequencies, and that high frequency wave was sent into the rolls. As soon as that wave met any deformation or holes, so it went back and it converted to electrical signal, and we got a display on our monitor display, that there is a presence of hole or deformation.
Fine. So what was the depth up till which you can identify the defect in this ultrasonic testing?
Sir, it was done in there was two options, sir. So first, we can do ultrasonic testing at the surface level. In that, we are using a high, about 5 megahertz frequency, sir. And when we are measuring the rows in the center, then we were sending a comparatively low frequency, sir, to measure it.
Is there any other NDT method that you can prefer apart from ultrasonic testing?
Sir, there is one more method which we can go, that is eddy current method, which can be used to find this one.
But eddy current is that we can only obtain that surface cracks, or internal cracks can also be obtained due to eddy currents.
Sir, on this, I'm not aware of this for eddy current, sir.
Okay, fine. You might be knowing about differential gear.
Yes, sir.
What is the purpose of using that?
Sir, it is used in automobile. When an automobile or engine takes a turn, in the turning, so two gears should have, because it is moving in a circle with a different radius. So first gear may have a different speed and the last gear may have a different speed. So in order to synchronize those speed, we use that differential gear.
So are we using differential in trains?
Sir, as per my knowledge, I think we are not using differential in trains.
So our trains are not taking turns left and right. They are moving in a straight line. Yes.
Sir, I'm not aware of it. Theoretically, it is possible, sir, but I'm not aware of it.
So can we use a differential gear in a train?
Yes, sir, we can use a differential gear on a train.
Sure. You might have seen the wheels of the train. They are mounted on a seam shaft. You cannot have a different RPM. Right?
Yes, sir.
How we can use a differential gear over there?
Sir, so we cannot use differential gear.
Then how the train is taking left or right turn? Definitely we might be having different in RPM.
Yes, sir.
But being a single shaft, how we can maintain that?
Sir, I'm not aware of it, sir.
Okay. You talked about IC engine, something to a diesel engine, right? Why diesel engine is being used for heavy vehicles? Why not petrol engine?
Sir, when in diesel engine, when our target is to generate more power or torque, then we go for, sir, heavy. Then we go for diesel engine, sir. And also, sir, if we talk on efficiency terms, so in diesel engine, the space is not the space is not the constant condition. So efficiency of diesel engine will be more compared to IC engine if the space is not constant.
Okay. There is one segment I need to ask from you. Is like work is having a unit of a joule, right? And we can say Newton meter also, precisely, right? But torque is also having a unit of Newton meter, but we are not using joule as a unit. Can you tell me, like, even though both are having the same unit, why we are not saying this much amount of joule of torque is being applied? Why we're only saying Newton meter?
Sir, both quantities are fundamentally and dimensionally different. when we talk about work, then it is a scalar quantity. So we have to use joule for that. But when we talk about torque, so it is a vector quantity. So it has to be differentiated. So we tell it as Newton meter.
Okay. Can you tell me what is knocking?
So knocking is a phenomena which occurs in the IC engines when unburned fuel, when there is a presence of I'm not able to recall this.
Okay. Could you tell me the difference between a refrigerator and an air conditioning?
Sir, a refrigeration, the prime target is to achieve a low temperature compared to the surroundings. But in air conditioning, we tend to change the condition of air, which is the humidity and the moisture content of the air.
Okay. So let us suppose it's a rainy season, right? So which is more advisable, a desert cooler or an air conditioner?
Sir, air conditioner is more advisable.
Okay. Why?
Sir, because if you use cooler, so cooler uses sprays tiny water droplets, and in a humid temperature, the water droplets will not evaporate. Thus, it will not cause any cooling. But at the same time, refrigerator tends to change the condition of the air by changing the moisture content. So it will be effective.
Okay. Can you tell me the difference between a tube and a pipe? Even though it's quite similar to, like, we are having tube, sometimes we are calling it as a pipe, but still, what's the major difference between these two?
Sir, pipe, I can say that pipe is used is a more strong structure which is used to carry fluids or fluids like water, gas. But on the same side, tube is a more flexible structure.
So,
Sir,
so pipe is not flexible according to you, I think.
Sir, the strength wise, it is not as strong as tube. Pipe tube is not strong as pipe.
Which is not strong, tube or pipe?
Sir, tube.
Tube is not strong. Pipe is
Sir,
a stronger one.
Yes, sir.
So we are using that hose pipe for gardening. So we will be calling it as a tube or a pipe.
Sir, it will be called as pipe only.
Pipe only.
Yes.
So even though it is not having that much of strength.
Sir, I mean to say that it depends on the application. That whenever our application, whenever we have to use the, whenever we are using where we don't want, sir, where we don't want the pipes to, means it should be, sir, fixed. It should not lose its shape and size. Then we are using pipes, sir.
Okay. One last question. Could you do let me know why we are using shielding in heat transfer?
Sir, shielding, sir, actually in radiation, shielding helps us to reduce the net radiation between two surfaces. So to reduce the net radiation transfer, we use shielding.
And how we can increase or alter any parameter that you can tell me?
Sir, we can add means we can add more shields. Means
no, we are not. It is like, what is the surface phenomena that we can change? We cannot add more or we can subtract. What parameter we can change by doing that? We can increase or decrease that resistance. Any parameter?
Sir, we can increase the space resistance by moving by maintaining a distance from the shield. The space resistance will increase.
Sure.
No, it will not. It is on by HL. No.
So one last question from industrial, because you said
yes, sir.
Right. You might have heard about MRP.
Yes,
right?
sir.
And MRP2 also. What's the price difference between these two?
Sir, MRP stands for Material Required Planning. it takes, sir, MRP takes inputs like bill of materials, master production schedule, and the current inventory file in order to predict the material which is required in the industry. MRP2, sir, MRP2 is little bit advancement of over MRP1, which stands for, sir, actually it's sir, I'm forgetting out MRP2, but I need to revise.
No problem, no problem. Negi sir.
Okay.
Sir, I would like to ask one more question, Abhishek. So as you said, industrial and production. So one more question is like, what is the difference between transportation and transshipment problems?
So transportation and
Transshipment problems.
so
Transportation and transshipment.
So transportation problem is a special case of LPP problem, where the aim is to minimize, aim is to specify the best path from supply of factory to the to its respective demands. So transshipment problem, sir, I'm not aware of.
Okay.
One addition to this, because it was LPP was talking about. Can you tell me the application of LPP in real life, apart from transportation and assignment, where we are actually using this LPP?
Sir, LPP can be used anywhere where we want to make a decision based on data, because, sir, it is a optimization tool used in industrial engineering where we want to optimize or use our resources to its optimum level. So,
any practical example?
Sir,
Apart from
sir, LPP, sir, can be used in a small workshop also, where we have 2 machines and few resources. In order to allocate the best available resources to those machines, we can apply LPP to find the optimum level.
Okay, we need to optimize the resources.
Yeah, yes, sir.
Okay. Can we use in diet chart? If you want to make a diet chart, can we use over there?
Yes, sir, we can use die chart, or we just need to identify the decision variables while designing an LPP model. So if we are able to grasp the decision variable in die chart, we can design an LPP model for that also.
So what could be the constraints and what could be the variables that you can define if you're having a die chart problem?
Sir, it depends on the regular calorie. I can say that the sum constant should be the sum of vitamins taken per day should be less than some fixed value. Sum of carbohydrate should be less than some fixed value. Similarly, sir, for different variety of foods, we can have these type of constants.
Okay. Okay, sir. Thank you. Thank you. Negi, sir.
Okay. Abhishek, your interview is over. अब रिलैक्स हो जाओ आप थोड़ा. ठीक है. हम आपको फीडबैक दे देते हैं. मैं अपना फीडबैक दे देता हूँ, फिर बाकी जो सर हैं वो भी फीडबैक दे देंगे. अभिषेक, आपसे पॉजिटिव वाइब्रेशंस आए पूरे इंटरव्यू में. 1-2 चीजें हैं जो थोड़ी और ज्यादा सही हो सकती हैं. एक बार मैंने आपसे पूछा कि HAL आप क्यों ज्वाइन करना चाहते हैं, तो आपने कहा बहुत बड़ा PSU है, ऐसा कुछ आपने कहा. तो बेटर होगा कि वहाँ पे आप महारत्ना PSU बोलें, और तो मतलब लगेगा कि आपके आंसर को थोड़ा सा और वो अच्छा करेगा कि आप बड़ा PSU क्या, मतलब एक इंजीनियर है आप ऑलरेडी, मतलब ऐसा भी नहीं है कि आप 4th ईयर के बाद डायरेक्टली आप जॉब करने आ रहे हो, ऑलरेडी आप TCS में काम कर चुके हो. तो वो थोड़ा सा आंसर आप वहाँ पे अच्छा कर सकते थे कि बड़े PSU या ऐसे वर्ड से अच्छा आप महारत्ना ऐसा बोलो, तो महारत्ना PSU है ऐसा. दूसरा, एक बार मैंने क्वेश्चन पूछा कि आप 5 साल बाद अपने आप को कहाँ देखना चाहते हैं, तो 5 साल बाद अपने ऐसा, मतलब ऐसा कोई जरूरी नहीं है कि आपको यही बोलना है कि HAL में मैं ये करूंगा वो करूंगा, मैं अपनी स्किल यूज करूंगा. आप ऐसे बोल सकते हैं कि मैं जिस भी PSU में होऊंगा या जिस भी जगह पे होऊंगा वहां पे कुछ ऐसा काम करना चाहूंगा जो रिसर्च ओरिएंटेड हो, या जो भी आपका जहाँ पे आप एक्चुअली अपने आप को देखना चाहते हैं रिसर्च ओरिएंटेड हो. मेरी टीम में कुछ ऐसे लोग हों और मैं कुछ ऐसा बिल्ड करना चाहता हूँ या ये करना चाहता हूँ, उसको आप बोल सकते हैं. और सबसे इम्पोर्टेंट फीडबैक मेरी तरफ से कि जितने भी टीचर्स ने क्वेश्चंस पूछे ना, उनका हर पॉइंट पे आप टेक्निकली करेक्ट होना चाह रहे थे। मतलब मे बी मैं रॉन्ग हूँ। आपको ऐसा मेरे को नहीं लगा कि किसी भी समय आपने अपने मन के अंदर से ऐसा सोचा कि मैं उस आंसर को थोड़ा और बेहतर तरीके से प्रेजेंट करूं। ये मेरा अपना ओपिनियन है। आपका हमेशा, मेरे को जो फीलिंग आई साइकोलॉजिकली, आपको ऐसा लग रहा था कि मैं उसका टेक्निकली सही आंसर दे दूं। पर मतलब टेक्निकल तो मैं हमेशा हर बच्चे को एक ही चीज बोलता हूँ इंटरव्यू में यार, मेरे को लगता है बाकी सर बार बार बोर भी हो गए होंगे सेम स्टेटमेंट सुन के कि टेक्निकली तो वो आपका देखना चाहते तो 10 क्वेश्चन और डाल देते हैं एचएल के पेपर में ना। इंटरव्यू के लिए बुला रहे हैं मतलब पर्सनैलिटी टेस्ट कर रहे हैं, पर्सनैलिटी टेस्ट कर रहे हैं, मतलब आपके सिर्फ टेक्निकल आंसर, टेक्निकली कितना करेक्ट है वो नहीं, पर किस तरीके से प्रेजेंट किया। दूर से बैठने से जो मेरे को लगा वो ये लगा कि आप हमेशा टेक्निकली सही होना चाह रहे हो। आपने कभी भी ऐसा अपने अंदर से नहीं सोचा कि मैं इस आंसर को और अच्छी तरीके से प्रेजेंट करूं। हो सकता है सोचा हो, पर ऐसा लग नहीं रहा था। ऐसा आपने, मैं सही हूं क्या?
यस सर।
ना तो आप बहुत सारी जगह क्या हुआ कि आपने जैसे ही क्वेश्चन पूछा आपने झट से एक स्टेटमेंट बोल दिया, फिर आपको लगा कि नहीं ये नहीं वो है, फिर आपने 10 सेकेंड 4 सेकेंड पॉज ले लिया। तो वही 4 सेकेंड पॉज आपने पहले लिया होता तो फिर आप वो जो पहला स्टेटमेंट आपने बोला वो आप बोलते ही नहीं और आपका आंसर ज्यादा अच्छा प्रेजेंट हो सकता था, है ना। तो आप अपने माइंड में ना बस कैसे भी करके उस समय ये याद रखना जब आपका एक्चुअल इंटरव्यू होगा कि मेरे को आंसर अच्छे से प्रेजेंट भी करना है। ठीक है। तो ये मेरी तरफ से फीडबैक था, बाकी सर लोग जो भी आपके फीडबैक है।
और
बाकी आप सब कुछ
अभिषेक,
जानते होंगे, आप ऑलरेडी बायजूस स्टूडेंट हैं। तो सबसे पहले तो कॉन्ग्रेचुलेशन, आपने बायजूस को सबको इतना प्राउड फील कराया कि सिलेक्शन हुआ। होपफुली फाइनल सिलेक्शन भी होगा। हाँ सर, आप कुछ कह रहे थे।
सो
थैंक यू सर।
अभिषेक, एज यू, जैसे कि आपने मेंशन भी किया था कि प्रोडक्शन आपका फेवरेट है, तो जैसे सर ने ऑलरेडी बोला प्रेजेंटेशन तो थोड़ा सा आपको उस पर काम करने की जरूरत है। तो और दूसरी चीज ये है कि अगर आपको कोई चीज नहीं भी आती है तो आप पहले बोल सकते हो सर आई डोंट हैव एनी आइडिया अबाउट दैट बट आई वुड लाइक टू ट्राई। क्योंकि कुछ जगह पर ऐसा था कि आपको नहीं पता था बट आपने आंसर करने की कोशिश की, तो उसके लिए थोड़ा परमिशन ले सकते हो अगर ऐसा हो तो। ठीक है। और दूसरा, जैसे आपने सोम को भी फेवरेट बोला था, ऐसा नहीं कि फेवरेट है तो मेरे को उसमें सब आता ही होगा। तो जैसे कोर करने वाला जो था उसमें आपने थोड़ा सा रोंग आंसर किया था। तो ये जो क्वेश्चन है एक बार ये थोड़े से देख लेना, कॉमन से क्वेश्चन है। और थोड़ा सा क्योंकि ऑनलाइन है तो आई कांटेक्ट का उतना समझ में नहीं आता, तो आई कांटेक्ट का भी थोड़ा ध्यान रखना कि जब आप वहां पे आंसर करो तो आपको इधर उधर नहीं देखना। बीच बीच में ऐसा हुआ जो आप नहीं जानते तो क्वेश्चन में आपने आई इधर उधर की, तो वो नहीं करना है। ठीक है, उस चीज को भी थोड़ा सा अवॉइड करना। तो बाकी मेरे ख्याल से सर ने बहुत अच्छी बातें बताई आपको, थोड़ा सा प्रेजेंटेशन पे वर्क करो। ठीक है। और जैसे
हाँ, मेरा भी यही मैंने भी यही नोटिस किया आपके टेक्निकल को लेके। आप बहुत काम और कंपोज्ड हो, नो डाउट अबाउट दैट। आप कॉन्फिडेंट भी हो। जितना कॉन्फिडेंस आप क्वेश्चन को जवाब देने में शो कर रहे थे, उसके बाद आप थोड़े थोड़े लैक ऑफ कॉन्फिडेंस, आउट ऑफ ट्रैक जाने लगे थे। ऐसा लग रहा था कि यू स्टार्टेड बीटिंग अराउंड द बुश। और जो कोई टेक्निकल अगर क्वेश्चन पूछ रहा है तो ही इज कंफर्टेबल विद दैट एरिया। तो आप उसको, कई कई ऐसे क्वेश्चंस थे जहां पे कोई एक पर्टिकुलर वर्ड ही चाहिए था। जैसे मैंने पेट्रोल इन सीआई इंजन, आप डिटोनेशन वर्ड यूज करते तो मुझे बड़ा अच्छा लगता, पर आपने पूरा घुमाया इधर उधर कि ऐसे हो सकता है वैसे। ऐसे ही सर ने पूछा इसमें ट्रांसपोर्टेशन और ट्रांसशिपमेंट में, तो ट्रांसपोर्टेशन जानना ज्यादा इंपॉर्टेंट नहीं था पर आपने बहुत टाइम लिया, तो हमें उम्मीद ये थी कि आप थोड़ा सा उसके बारे में बोलोगे जो जो आपको स्टैंड आउट करेगा। पर आपने तो मतलब आपने एक्सटेंड किया अननेसेसरली उस चीजों को, कई चीजों को एक्सटेंड किया। आपको पता था कि आपको नहीं पता है, वो चीज नहीं पता है जो सर सुनना चाहते हैं। तो वो थोड़ा सा उसमें आप अननेसेसरली चीजों को एग्जेजरेट करने की जरूरत नहीं है। उससे क्या थोड़ा सा आप लैक ऑफ कॉन्फिडेंस, आउट ऑफ ट्रैक जाना, तो क्योंकि टेक्निकल पिन पॉइंट होते हैं क्वेश्चन। सर ने भी, क्योंकि आप फंसते चले जाओगे, स्टार्ट कर दोगे आप, फिर आप आपके क्वेश्चन में दूसरा क्वेश्चन निकलेगा तो बहुत अंदर घुसते चला जाएगा और बाद में बोलोगे नहीं सर आई वाज रॉन्ग। तो फिर वो थोड़ा सा
वो
नेगेटिव
वो
इम्पैक्ट।
एक्चुअली सर क्या होता है ना कि कॉलेज में हम वाइवा देते हैं ना, तो
एग्जैक्टली
वहां पे
मैं
ऐसा
वही
होता
कह
है।
रहा था भाई
वहां पे
वाह।
मैं खुद ऐसा करता था कि वहां पे क्या उनका ऐसा माइंडसेट है कि कोई बच्चा चुप रहा तो कम मार्क्स देना है। और जिसने चाहे घुमा फिरा के भी कुछ भी उल्ट, मतलब ए पूछा तो बी सी बोल दिया बस सही, चाहे बी सी बोला अलग क्वेश्चन आंसर दिया पर सही दिया तो उसको मार्क्स ज्यादा मिल जाते हैं। जनरली ऐसा होता है। तो
हाँ
वहां
हाँ
से स्टूडेंट का ऐसा थोड़ा सा माइंडसेट आ जाता है।
वही मैं एग्जैक्टली वही बोल रहा था कि ये तुमने वाइवा वाली हैबिट अभी रखी हुई है। तो इसमें तुम्हें मतलब करना ये चाहिए था कि आप ये कह सकते थे सर कि ट्रांसपोर्टेशन आई हैव आइडिया,
हाँ।
ट्रांसशिपमेंट आई डोंट हैव, क्योंकि मैंने आपसे डिफरेंस पूछा था, मैंने ये तो पूछा नहीं था ट्रांसपोर्टेशन क्या होता है। उसके बाद मैं आपसे बोलता ठीक है ट्रांसपोर्टेशन बताओ, तो आप बता देते हैं। ठीक है, तो इसको थोड़ा सा इस तरीके से डील करना है। और
मेरे
मतलब
मेरे कुछ कुछ वो बेसिक क्वेश्चन थे, मुझे काफी कुछ गलत ही लगे, मतलब जो आपने जवाब दिए।
हाँ
नोजल में मैं जानना चाह रहा था वो कि आप सुपरसोनिक सबसोनिक वर्ड यूज करो, पर आप बस कन्वर्जिंग बोलते चले गए। उसी तरीके से मैंने और क्या पूछा था, प्रेशर कुकर के बारे में पूछा तो आप फिर एंथैल्पी इंटरनल एनर्जी, थोड़ा सा वेग आइडिया है, आप मैथमेटिक्स बताने लग गए। मतलब आपको ऐसा लगे कि आपको वो वाली अवेयरनेस नहीं है जो होनी चाहिए थी, क्योंकि बेसिक टर्म्स हैं इंटरनल एनर्जी एंथैल्पी। तो बाकी तो ठीक है, बाकी आप निकाल लोगे, आप अच्छा परफॉर्म किया है आपने।
थर्मल और फ्लूइड एक्चुअली प्रिपेयर हम नहीं किए थे।
स्टूडेंट से बात करें अभी जब
हाँ।
क्यों सर?
बोले
हाँ।
हम किए ऐसा किए तो पूछे थे ऐसा करके आप बात की, अब लगा अभी फीलिंग आई बोकारो वाली। और कोई यार अभिषेक आपके कोई क्वेश्चंस?
बस सर क्वेश्चन तो सर कुछ नहीं है, बस यही सर, हम आप जो बोले हम वो भी, हम अपना भाई से भी इंटरव्यू वो भी मेरा ले रहा है, मतलब हम प्रैक्टिस करते रहते हैं, तो मेरे को भी यही आप जो बोले वही प्रॉब्लम है कि हम जल्दी रिएक्ट करना चाहते हैं, तो शांति से सुनना चाहिए पहले। सर एक्चुअली इस इंटरव्यू में काफी सारा क्वेश्चन जो हम प्रिपेयर नहीं किए थे वो पूछ लिया गया, इसलिए हम और ज्यादा पैनिक हो गए थे, तो वरना हम मतलब हम शांति रहते हैं ऐसे तो।
नहीं, पर वैसे आपने बहुत अच्छे जवाब दिए,
अच्छा मैं बोला ना सबसे
तरीका
पहला
बहुत
चीज आपसे पॉजिटिव वाइब्रेशन आया, मेरे को बहुत अच्छा पॉजिटिव वाइब्रेशन आया कि बहुत मेहनती बच्चा है और काम के प्रति सिंसियर है, ऐसा वाइब्रेशन आपसे आया।
थैंक यू सर।
हाँ, ये पॉइंट्स हम बता रहे हैं तो इससे वो ऐसे नेगेटिवली मत लेना कि आपने
नहीं
बहुत
नहीं सर,
गंदा परफॉर्म किया है, या ऐसा नहीं है। हम तो आपको और फर्दर इम्प्रूवमेंट हमें जो लगता है क्या हो सकता है, बाकी आपने
थैंक यू,
बहुत अच्छा।
थैंक यू सर।
इंटरव्यू में कोई भी आप कोई एक्सपर्ट देखो नहीं हो पाएगा, ये तो फ्रैंकली अगर आपको नहीं आता सीधे सीधे बोलिए, उसमें आप ज्यादा घुमाएंगे ना तो आप फंस जाएंगे।
जी
अब
सर।
जैसे आपके जो प्रोफाइल में देखा था, आप कोशिश की क्योंकि आपका प्रोडक्शन और इंडस्ट्रियल है ना, तो आपका
हाँ
जो ट्रेनिंग वाला है टॉपिक जिससे आपने
हाँ
सोनी का बताया था,
हाँ।
तो उसमें से अच्छे क्वेश्चन आपसे पूछे जा सकते हैं। मैं तो चलो ओवरव्यू बोल दिया, आप और भी एनडीटी के बारे में और भी चीज पढ़िए, इसके अलावा भी क्या क्या है वो देख लीजिए। एडी करंट के ऊपर देख लीजिए, आपने एडी करंट खुद बोला तो इसलिए मैंने उस पर और पूछा, तो एडी करंट के बाद और भी चीजें पूछ सकते हैं। तो थोड़ा सा उसके जो भी है ना +-5-10% का जो भी सिलेबस है एक बार थोड़ा देख लीजिए, क्योंकि वो आपकी प्रोफाइल में लिखा हुआ है और वहां से वो डेफिनेटली दे गोना आस्क यू क्वेश्चन। तो वो एक बार थोड़ा आप देख लीजिएगा। बाकी तो ओवरऑल इट वाज गुड, मतलब मेरी तरफ से कोई इतना इश्यू नहीं था, थोड़ा सा बस टेक्निकल का थोड़ा ब्रशअप की जरूरत है बस, और कुछ नहीं।
यस सर, थैंक यू।
और कोई क्वेश्चन अभिषेक आपका?
नहीं सर, बस आप लोग का बस ब्लेसिंग चाहिए बस, और कुछ नहीं।
पूरा हमारा आपके साथ सपोर्ट है, आपके इंटरव्यू तक भी कोई भी आपको डाउट हो तो आप हमसे कनेक्ट कर सकते हैं। ठीक है,
थैंक यू सर।
ओके, थैंक यू।
ओके,
चलिए, ऑल द बेस्ट।
ओके अभिषेक, ऑल द
थैंक यू
बेस्ट।
सर, नेक्स्ट, थैंक यू।